Picture this, over 3 million squids being caught and processed every single day across the world's oceans, with specialized fishing fleets harvesting more than 4 million tons of these remarkable cephalopods annually. Imagine processing plants operating continuously, transforming fresh squid into billions of dollars worth of products that supply restaurants, grocery stores, and food manufacturers in over 90 countries worldwide. What if I told you that the global squid industry generates more than $15 billion in revenue each year, making it one of the most valuable marine fisheries on Earth, yet operates with fishing and processing technology so advanced it rivals aerospace engineering? Welcome to AgriCraft, where we explore the cutting edge of food production technology and sustainable agriculture practices. I'm your host, and today we're diving into the extraordinary world of commercial squid fishing and processing, an industry that represents one of the most technologically sophisticated forms of marine agriculture ever developed. From the massive factory ships equipped with underwater lighting systems that can be seen from space, to the state-of-the-art processing plants where automated systems handle thousands of squid per minute with surgical precision, we'll follow these incredible creatures through their complete journey from the deep ocean to dinner tables around the world. All will be revealed in this video. The history of squid fishing dates back over 1,000 years, with ancient Japanese and Mediterranean fishermen developing ingenious techniques to capture these elusive creatures of the deep. What began as small-scale nighttime fishing with torches and simple nets has evolved into one of the world's most sophisticated marine industries, utilizing technology that transforms the ocean into vast underwater farming fields. Today's squid industry represents a triumph of marine agriculture innovation and international cooperation. The global squid fishery supports over 200,000 jobs across dozens of countries, with vessels from Japan, China, Argentina, and Peru participating in carefully managed operations that span every major ocean. This isn't traditional fishing anymore. It's precision marine agriculture that combines advanced technology, scientific research, and sustainable practices to harvest one of the ocean's most abundant and nutritious protein sources. The economic impact of squid fishing extends far beyond the fishing vessels themselves. Processing facilities, freezing operations, packaging systems, and global distribution networks create employment for millions of workers worldwide. Japan alone processes over 600,000 tons of squid annually, much of it destined for domestic consumption, where squid represents a dietary staple worth over $3 billion to their economy. What makes squid fishing particularly fascinating from a marine agriculture perspective is the incredible innovation required to harvest these intelligent, fast-moving creatures. Modern squid fishing vessels are floating cities equipped with underwater lighting systems that consume more electricity than small towns, creating artificial ecosystems that attract squid from miles away. These operations represent some of the most energy-intensive agriculture on Earth, yet produce protein with remarkable efficiency. The scale of global squid fishing is truly breathtaking. China operates the world's largest squid fishing fleet with over 3,000 vessels capable of harvesting over 1 million tons annually. These floating factories can process and freeze squid at sea while remaining on fishing grounds for months at a time, creating a marine agriculture system that operates independently of land-based infrastructure. The transformation from traditional fishing to modern marine agriculture represents one of the most remarkable technological achievements in food production. Where historical squid fishing was limited to coastal waters and seasonal availability, today's operations utilize satellite technology, underwater robotics, and artificial intelligence to locate and harvest squid in the deepest ocean waters year-round. Modern squid fishing has also revolutionized our understanding of marine ecosystems through the development of fishing techniques that work with natural behavior patterns rather than against them. The use of underwater lighting systems mimics the natural bioluminescence that squid use for communication and feeding, creating controlled environments that attract squid while minimizing impact on other marine species. The diversity of squid species harvested commercially creates opportunities for specialized processing and market segmentation that rival any agricultural commodity. From the massive Humboldt squid of the Pacific to the delicate market squid of California waters, each species requires unique fishing techniques, processing methods, and market applications that demonstrate the sophistication of modern marine agriculture. Let's explore how these remarkable operations actually function. beginning with understanding the unique biological characteristics and marine requirements that make squid such an important yet challenging commercial species. Understanding squid begins with recognizing that these remarkable creatures represent some of the most intelligent and adaptable marine organisms on Earth, possessing characteristics that make them both highly valuable and extremely challenging to harvest commercially. Unlike fish that swim in predictable schools, squid exhibit complex behaviors including sophisticated communication, rapid movement patterns, and intelligence that rivals many land animals. The biological characteristics that make squid commercially valuable include their rapid growth rates, high protein content, and global distribution across virtually every ocean environment. Most commercial squid species reach harvestable size within 1 to 2 years, with some species capable of growing from larval stage to adult size in just 6 months. This rapid growth cycle allows squid populations to sustain intensive fishing pressure while maintaining healthy stock levels under proper management. Squid species vary dramatically across different ocean regions, each adapted to specific environmental conditions and displaying unique characteristics that influence fishing methods and market applications. California market squid, small and tender, dominate American West Coast operations and command premium prices for fresh applications. Argentine shortfin squid, larger and meatier, supply global processing markets where they're transformed into everything from frozen rings to processed seafood products. The environmental requirements for squid populations include specific water temperatures, ocean currents, and food availability that create complex migration patterns spanning thousands of miles. These creatures follow ancient routes that bring them close to fishing grounds at optimal times. But unlike predictable fish migrations, squid movements can vary dramatically based on ocean conditions, food availability, and environmental factors that fishing fleets must constantly monitor and adapt to. Modern marine science has revolutionized our understanding of squid ecology through satellite tracking, genetic analysis, and behavior studies that utilize underwater cameras and acoustic monitoring. Scientists can now predict squid movements with increasing accuracy, allowing fishing fleets to position themselves more effectively while developing fishing techniques that work with natural behavior patterns rather than disrupting them. The natural diet and feeding behavior of squid contribute to their exceptional nutritional value and distinctive culinary characteristics. These creatures feed primarily on small fish, crustaceans, and other squid, creating a marine food web position that concentrates valuable proteins and minerals while maintaining the lean, tender texture that makes squid so prized in global cuisine. Population monitoring systems for squid represent some of the most advanced marine research programs in the world, utilizing everything from underwater robots to genetic sampling to track stock health and reproduction success. These monitoring programs provide the scientific foundation for sustainable fishing practices while helping fishing fleets optimize their operations for maximum efficiency and minimal environmental impact. The behavioral complexity of squid creates both opportunities and challenges for commercial fishing. Their intelligence allows them to learn and adapt to fishing techniques, requiring constant innovation in fishing methods. However, their natural curiosity and attraction to light sources provide the foundation for the sophisticated lighting systems that form the core of modern squid fishing operations. Squid reproduction cycles create seasonal availability patterns that fishing fleets must understand and adapt to for successful operations. Unlike many fish species that reproduce in specific locations, squid can reproduce in open ocean environments, creating population dynamics that require sophisticated monitoring and adaptive fishing strategies. The schooling and social behaviors of squid vary significantly between species and environmental conditions, requiring fishing vessels to utilize multiple techniques and technologies to successfully locate and harvest these creatures. Some species form massive aggregations during feeding or reproduction, while others remain solitary, demanding completely different fishing approaches. As fishing vessels locate squid populations using advanced detection technology, they deploy some of the most sophisticated harvesting systems ever developed for marine food production, beginning the transformation from wild ocean creatures to processed food products. The harvest stage in squid fishing represents where traditional maritime knowledge meets cutting-edge marine technology. Modern squid fishing vessels are floating technological marvels equipped with lighting systems, fishing gear, and processing equipment that rivals the sophistication of offshore oil platforms. Harvest timing in squid fishing depends on understanding complex migration patterns, environmental conditions, and behavioral cycles that vary significantly between species and fishing grounds. Peak squid fishing often occurs during nighttime hours when these creatures naturally rise from deep waters to feed near the surface, requiring fishing operations to coordinate their activities with natural behavior patterns. The lighting systems that form the core of modern squid fishing represent some of the most powerful artificial lighting installations on Earth. These underwater lighting arrays can consume over 1 megawatt of electricity, creating artificial daylight conditions underwater that attract squid from distances of several miles. The technology behind these lighting systems includes everything from high-intensity LED arrays to sophisticated control systems that can adjust light intensity, color spectrum, and timing to optimize squid attraction. Net deployment in squid fishing utilizes specialized techniques developed specifically for these fast-moving, intelligent creatures. Purse-seine nets designed for squid fishing incorporate unique features including fine mesh construction, rapid deployment systems, and specialized closing mechanisms that can capture entire squid aggregations before they can escape using their remarkable swimming abilities. The actual catching process requires precise coordination between lighting systems, net deployment, and vessel positioning to successfully harvest squid aggregations. These operations often involve multiple vessels working in coordination, with each ship playing a specific role in the complex dance of attracting, containing, and harvesting squid schools that can disappear in seconds if disturbed. Mechanical harvesting systems aboard modern squid fishing vessels include hydraulic net haulers, fish pumps, and automated sorting equipment specifically designed to handle the unique characteristics of squid. These creatures require gentler handling than most fish to prevent damage to their delicate flesh, necessitating specialized equipment that can move large volumes of squid while maintaining product quality. The processing of squid often begins immediately after capture, with many fishing vessels equipped with complete processing lines that can handle squid from initial sorting through final packaging. Onboard processing is critical for squid due to their extremely short shelf life and tendency to deteriorate rapidly after death, making immediate processing essential for maintaining product quality and market value. Quality assessment during harvest involves evaluating squid size, freshness, and species identification to determine optimal processing methods and market applications. Premium squid are often processed for fresh markets, while smaller or damaged specimens are directed toward processing lines for frozen products or manufactured applications. The scale of modern squid fishing operations can be truly spectacular. Individual fishing vessels can harvest over 500 tons of squid during successful fishing trips, with the largest operations processing thousands of tons during multi-month voyages. These volumes require sophisticated handling systems and processing equipment that can manage enormous quantities of delicate seafood while maintaining quality standards. Storage systems aboard squid fishing vessels must maintain captured squid at precise temperatures and conditions that preserve quality during processing operations. Refrigerated seawater systems keep squid at optimal temperatures, while specialized handling equipment minimizes physical damage that could affect final product quality and market value. Transportation from fishing grounds to processing facilities or markets requires careful coordination of vessel scheduling, processing capacity, and global market demand. Many modern squid fishing vessels can process and freeze their catch at sea, allowing them to remain on productive fishing grounds for extended periods while maintaining product quality for international distribution. The efficiency of modern squid fishing operations represents one of the most technologically advanced forms of marine agriculture, with catch rates and processing capabilities that continue improving through innovation in lighting technology, fishing gear design, and onboard processing systems. As captured squid move from fishing vessels to shore-based facilities, they enter processing plants that represent some of the most specialized and technologically advanced seafood processing operations in the world. The processing stage begins immediately upon arrival at specialized squid processing facilities, where these delicate creatures encounter industrial systems specifically designed to handle their unique characteristics and the high volumes associated with commercial squid operations. These facilities often operate around the clock during peak fishing seasons, processing thousands of tons of squid daily while maintaining strict quality standards that preserve the texture and flavor characteristics that make squid valuable in global markets. Initial handling procedures at squid processing plants involve rapid unloading systems specifically designed to minimize handling time and preserve product quality. Conveyor belts transport squid from unloading areas through initial sorting and grading procedures that determine processing pathways based on size, species, quality, and intended end-use applications. The sterilization and cleaning protocols in squid processing plants exceed standards found in most seafood processing operations due to the delicate nature of squid flesh and its susceptibility to bacterial contamination. Workers undergo extensive hygiene procedures including sanitizing showers, complete protective clothing changes, and health monitoring protocols that ensure food safety throughout the processing operation. Quality inspection procedures begin immediately upon arrival, with trained inspectors evaluating each batch of squid for freshness indicators, size consistency, species identification, and overall condition. These initial assessments determine whether squid will be processed for premium fresh markets, frozen products, or value-added manufacturing applications, ensuring optimal utilization of each batch. Automated sorting systems utilize sophisticated technology including optical scanners, weight sensors, and size grading equipment specifically calibrated for squid processing. These systems can process thousands of squid per hour, while maintaining sorting accuracy that exceeds manual sorting capabilities, ensuring consistent product quality across large production volumes while accommodating the irregular shapes and sizes that characterize different squid species. The main industrial processing steps for squid vary significantly depending on intended end products and market requirements. Fresh squid processing involves careful cleaning, tentacle separation, and packaging operations that preserve optimal texture and appearance for restaurant and retail applications. Frozen squid processing requires different techniques including blast freezing, glazing, and specialized packaging that maintains quality during extended storage periods. Modern cleaning machines represent marvels of food processing engineering, capable of processing whole squid into clean tubes and tentacles in seconds, while removing ink sacs, internal organs, and cartilage with precision that exceeds manual processing. These automated systems utilize computer-controlled processing patterns that adjust for individual squid variations while maximizing yield and maintaining consistent product appearance. Industrial machines used in squid processing include everything from automatic feeders that orient squid for processing to specialized cutting equipment that can produce precise rings, strips, or portion-controlled pieces. These production lines integrate multiple processing steps, including cleaning, cutting, washing, and packaging, into continuous automated systems that operate with minimal human intervention while maintaining strict quality control. Temperature control throughout squid processing plants is absolutely critical due to the rapid deterioration rate of squid flesh at improper temperatures. Different processing areas maintain specific temperatures optimized for particular operations, with fresh processing areas kept just above freezing, while blast freezing operations utilize temperatures of -40 degrees Celsius to rapidly freeze products while preserving texture. Quality control procedures continue throughout every stage of squid processing, with trained specialists monitoring production lines continuously for consistency, safety compliance, and adherence to established quality standards. Products undergo regular testing for bacterial levels, temperature compliance, texture characteristics, and visual appearance that determine final product grading and market application. The processing of squid for different market segments requires specialized knowledge and equipment configurations that accommodate varying consumer preferences and culinary applications. Fresh squid processing emphasizes speed and temperature control to maintain optimal product characteristics, while frozen product processing focuses on texture preservation and extended storage stability through controlled freezing and packaging techniques. Waste reduction and byproduct utilization represent important aspects of modern squid processing, with specialized equipment designed to capture and process materials that were once considered waste. Squid ink, organs, and processing trimmings are processed into valuable secondary products that contribute to both economic efficiency and environmental sustainability. The processing of squid into value-added products includes everything from breaded calamari rings to squid-based surimi products that require specialized formulation and processing equipment. These manufactured products allow processors to utilize mixed grades of squid while creating consistent, branded products that command premium prices in retail and food service markets. Following the intensive processing procedures, squid products move into sophisticated packaging and distribution systems designed to preserve the delicate texture and flavor characteristics that make squid valuable while meeting the diverse requirements of fresh, frozen, and processed product markets worldwide. The packaging systems used in squid processing operations must accommodate the unique preservation requirements these delicate products demand while maintaining the specific texture and appearance characteristics that consumers expect. Automated packaging lines handle fresh, frozen, and processed products simultaneously, switching between packaging formats based on production schedules and market demands. Fresh squid packaging utilizes modified atmosphere systems that replace air with gas mixtures specifically optimized for extending shelf life while maintaining the firm texture and bright appearance that characterize quality fresh squid. These packaging systems can adjust gas compositions in real time based on squid species, processing method, and intended distribution timeline, ensuring optimal product preservation for each specific application. Vacuum packaging systems for premium fresh squid products remove all air while creating hermetic seals that prevent bacterial growth and oxidation that can cause texture deterioration and off flavors. These systems utilize specialized packaging materials designed to maintain flexibility at refrigerated temperatures while providing exceptional barrier properties against oxygen and moisture that could compromise product quality. Frozen squid packaging requires different considerations, with systems designed to prevent freezer burn while maintaining package integrity during frozen storage and transportation that can last months. Automated packaging lines for frozen squid products can handle multiple portion sizes and package formats while maintaining consistent package weights and preventing ice crystal formation that could damage product texture. Individual quick freezing systems for squid products utilize blast freezing technology that can freeze individual pieces to -18 degrees Celsius within minutes, preserving cellular structure and texture characteristics that distinguish premium frozen squid from inferior products. These systems incorporate automated handling equipment that prevents damage during the freezing process while maintaining consistent product quality. Labeling systems in squid processing facilities must accommodate complex regulatory requirements across multiple international markets that have varying standards for seafood labeling, nutritional information, and origin identification. Products destined for different countries require specific labeling formats that automated labeling machines can switch between instantly while maintaining accurate product identification and traceability information. Cold storage facilities in squid processing plants maintain multiple temperature zones optimized for different products and storage durations. Fresh products are stored at temperatures just above freezing, frozen products at -18 degrees Celsius, while processed products may require specialized storage conditions based on their specific formulations and preservation requirements. The distribution networks for squid products span the globe and require expertise in international shipping regulations, cold chain management, and product preservation during transportation that can take weeks to reach final destinations. Fresh products might reach markets within 24 hours of processing, while frozen products travel through conventional shipping networks that must maintain precise temperature control throughout the distribution chain. Quality control procedures extend throughout the packaging and distribution process, with products tested regularly for package integrity, temperature compliance, and microbiological safety that ensures products maintain safety and quality standards throughout their journey from processing plant to final consumer, regardless of transportation method or destination market. Traceability systems in modern squid processing utilize advanced tracking technology that allows individual packages to be traced back to specific fishing vessels, catch dates, fishing grounds, and processing batches. This comprehensive traceability provides critical information for food safety management while enabling processors to quickly identify and address any quality concerns that might arise in the complex global distribution chain. Shipping logistics for squid products require specialized knowledge of international trade regulations, seafood import requirements, and cold chain management across multiple transportation modes, including air freight for premium products and container shipping for bulk frozen products. Different countries maintain varying standards for squid imports, requiring expertise in navigating complex regulatory environments. The packaging and distribution systems represent the final critical link in the squid supply chain, ensuring that the delicate texture and flavor characteristics built into products throughout the fishing and processing stages reach consumers in optimal condition while meeting the demanding logistical requirements of global seafood distribution networks. Beyond the primary squid products, processing operations generate numerous valuable byproducts that contribute significantly to overall economic viability while demonstrating the comprehensive resource utilization possible in modern seafood processing operations. Squid ink represents one of the most valuable and unique byproducts in seafood processing, commanding premium prices in culinary markets where it's prized for its distinctive color, flavor, and nutritional properties. Modern processing facilities utilize specialized extraction equipment that can recover ink from squid processing operations while maintaining the purity and quality required for culinary and pharmaceutical applications. The ink extraction systems employ gentle processing techniques that preserve the delicate compounds responsible for squid ink's unique characteristics, while removing impurities and maintaining the sterile conditions required for food applications. This extracted ink sells for thousands of dollars per gallon to specialty food manufacturers, high-end restaurants, and pharmaceutical companies researching its potential health benefits. Squid meal production from processing waste provides valuable protein sources for aquaculture operations and specialty animal feeds. Specialized drying and grinding equipment converts squid heads, organs, and processing trimmings into high-protein meal that contains unique amino acid profiles particularly valuable for marine aquaculture applications, where squid-based feeds can improve growth rates and product quality. The processing of squid waste into meal utilizes thermal processing systems that cook and dry materials while preserving protein quality and digestibility. These systems can process thousands of pounds of waste materials daily while producing consistent grades of squid meal that meet specific nutritional requirements for different aquaculture and animal feed applications. Chitosan extraction from squid pen structures provides valuable materials for pharmaceutical and industrial applications. The cartilaginous pen that provides structural support in squid contains chitin that can be processed into chitosan, a biopolymer with applications in wound dressings, dietary supplements, and biodegradable packaging materials that command premium prices in specialized markets. The processing of squid organs into specialty products includes everything from liver oil extraction to the production of enzymatic compounds used in food processing and pharmaceutical applications. These specialized processing operations require sophisticated extraction equipment and quality control procedures that ensure products meet the purity standards required for their intended applications. Even the water used in squid processing can be processed to recover valuable proteins and minerals through concentration and filtration systems. Modern water treatment facilities can extract dissolved nutrients while producing treated water that meets environmental discharge standards, contributing to both resource utilization and environmental compliance. The comprehensive utilization of squid processing byproducts requires sophisticated equipment and specialized knowledge of multiple markets that may have completely different quality requirements and regulatory standards. Ink processing systems, meal production equipment, and specialized extraction technology represent significant capital investments that contribute to both economic efficiency and environmental sustainability. Quality control for squid byproducts maintains the same rigorous standards applied to primary food products, with specialized testing procedures that ensure products meet the specific requirements of their intended applications. Squid ink undergoes purity testing and microbiological analysis, while squid meal is tested for protein content, amino acid profiles, and contamination levels. The markets for squid byproducts continue expanding as new applications are developed for these unique materials. Research into squid-derived compounds for medical applications, specialty food ingredients, and industrial materials creates new revenue opportunities for processors willing to invest in specialized processing equipment and market development. The economic impact of byproduct utilization can represent 20 to 30% of total revenue for well-managed squid processing operations. This additional income stream helps offset processing costs while contributing to environmental sustainability through comprehensive waste reduction and resource utilization that maximizes the value extracted from each squid processed. When it comes to culinary applications and nutritional value, squid represents one of the most versatile and nutritious seafood options available to consumers, supporting a diverse range of food products and preparation methods that span cultures and cuisines worldwide. Squid offers exceptional nutritional density that makes it one of the healthiest protein sources available in global food markets. A single serving of squid provides over 20 grams of high-quality protein, while containing less than 2 grams of fat, making it ideal for health-conscious consumers seeking lean protein sources. The protein in squid contains all essential amino acids in optimal proportions for human nutrition. The nutritional profile of squid includes exceptional levels of vitamin B12, selenium, and phosphorus, nutrients that are essential for nervous system function, immune system health, and bone development. Squid provides more vitamin B12 per serving than most other seafood sources, making it particularly valuable for individuals following diets that might be deficient in this critical nutrient. Different squid species offer varying culinary characteristics that suit different preparation methods and cultural preferences. Market squid provides tender texture and